Alright, here's a quick overview of calculating different volumes. First is volumes when cross sections are squares. So here's one side and you have squares coming out. Okay, so the area of a square is side squared. So one side is f of x minus g of x. And then we're going to square it. It's going from 1 to 6. Okay, equilateral triangles. Again, one of the sides is on this area coming out at you. It's going to be square root of 3 over 4. F of x minus g of x squared. It's top minus bottom. Semicircles. Okay, area of a semicircle is 1/2 pi r squared. 1/2 pi r. Remember, r is going to be half of the diameter. So that's the diameter. F of x minus g of x, we want half of that. And we're going to square it. Another way to think about it is 1/8 pi times the volume of the square. Alright, the rectangles one's a little different because they have to give you something about the height of the rectangle. So the width we know is the function, or sorry, the difference in the functions. But the height could be anything. It could be twice the base. It could be x. It could be some function. It could be x squared. You never know. So times whatever they say the height is. If the height is 3 times the base, then it's just 3 times f of x minus g of x. Alright, what about when you rotate? If we rotate around the x-axis, just my little rotation thing. Okay, I always draw a rectangle. It's going to be the outer radius squared minus the whole, or the inner one. Okay. Alright, y equals -2 is down here. Okay, again I draw my rectangle. Pi times the integral from 1 to 6. Outer. So that's top minus bottom. Minus the whole, which is this distance right there. Y equals 7 is above. So I'm going to draw my rectangle. Okay, this time the farthest distance is 7 minus g of x minus the whole, which is 7 minus f of x. Alright, rotating around the y-axis. I don't know anything else, so I'm going to have to use shell method here. I have a couple examples later on where I don't use shell method. So if you haven't watched that video, this might be a little confusing. But it's going to be 2 pi times the integral from 1 to 6. The radius, which is the distance from my rectangle to my axis, times my height. If I'm rotating around -1, here's my rectangle. Okay, the distance from my rectangle to the axis is x minus -1 times my height. Alright, x equals 10 is over here. It's going to be 2 pi times the integral. Here's my distance to my rectangle. Sorry, there's 10. So that's going to be 10 minus x times my height. Alright, now these are actually functions in terms of y. So this is what we're used to. I don't have any bounds, I'm not sure why, but let's go with 1, 2, 3, 4, 5, 6. So I'll still go from 1 to 6, and it's going to be the outer minus the whole. Alright, y equals -1. Pi times the integral from 1 to 6. It's 1 to 6 this time because your y values go from 1 to 6. The outer minus the whole. X equals 8 is over here. This time the outer is going to be 8 minus g of y. Minus the whole, which is 8 minus f of y.